Lesson 5-2, greatest common factor. So the greatest common factor is just the largest factor in common among multiple numbers. Now a factor, remember, is just those numbers that you are multiplying to get a product. So when two numbers only have 1 as a common factor, they are considered relatively prime. Equivalent fractions have the same value but are written with different numbers. So in this video, we're going to be going through finding the greatest common factor and then reducing fractions with finding the greatest common denominator. So there are a couple ways that you can find the greatest common factor. First method is just list of factors, which means you're identifying the biggest common factor among the list. Or you can use prime factorization, where you're going to multiply the common prime factors. So let's take a look at our first example. Students are planting 18 forsythia and 24 lilac bushes around the school in groups of equal number. Each group must have the same type of bush. What is the greatest number of bushes the students can plant in each group? So we have 18 and we have 24. Now if I were to list all the factors of 18, this would be 1, 2, 3, 6, 9, and 18. And 24 would give us 1, 2, 3, 4, 6, 8, 12, and 24. Now you can see here that the biggest number that they have in common would be 6. Now if I were to do prime numbers, 18 would give us 2 times 3 times 3, and 24 would give us 2 times 2 times 2 times 3. Now the common factors that they have, common prime numbers, are they have 2's and they have 3's. It doesn't matter how many they have of each, as long as they both have those two factors. I would just multiply them. 2 times 3 is 6, and there would be our greatest common factor. Next, find the greatest common factor of 27, 36, and 63. Now I'm going to do prime numbers here. So 27 would be 3 times 3 times 3. 36 would be 2 times 2 times 3 times 3, because that's 4 times 9, and 4 times 9 is 36. And 63 is 9 times 7, so that'd be 3 times 3 times 7. They all have 3 in common. They all have 2 3's in common. So 3 times 3 would give us 9. Next, find the greatest common factor of 20 and 45. So again, I'm going to do prime numbers for these. So 20, this would be 4 times 5, and 4 is 2 times 2, and then I have times 5. 45 would be 3 times 3, which is 9, and 9 times 5 is 45. So here the common factor, or common prime numbers I only have would be 5. Next, find the greatest common factor of 10 and 24. So 10 would be 2 times 5, and 24 would be 8 times 3, and 8 is 2 times 2 times 2, and 3. They both have at least 2, so the greatest common factor amongst them would be 2. And find the greatest common factor of 6, 14, and 28. So 6 would be 2 times 3. 14 is 2 times 7. So right now it looks like it's going to be 2. 28 is 4 times 7, and 4 is 2 times 2, and then times 7. So the only factor that they have in common is just 2. Next, find the greatest common factor of 8, 16, and 36. Here, if we did the prime numbers, so 8 would just be 2 times 2 times 2. 16 is 2 times 2 times 2 times 2. and 36 is 2 times 3 times 2 times 3. So now if I circle what they have in common, all three of them have this 2, and all three of them have this 2. So that'd be 2 times 2, which will give us 4. So the greatest common factor amongst all of them would be 4. Next is now reducing fractions. So writing them in simplest form, and when you write fractions in simplest form, you can use the greatest common factor or prime factorization to do that. Or here, if you do another way, is just break it down with its factors, which 49 is 7 times 7, and 56 would be 7 times 8. They both have 7s you can divide out. That leaves us with 7/8. I cannot reduce it any further. Next, 12/20. I know that this would be 6 times 2, and 30 could be 6 times 5. 6 is the greatest common factor. They can divide them out, and I'm left with 2/5. Next, 22/55. This would be 11 times 2, and the denominator would be 11 times 5. The 11s divide out, and I'm left with 2/5. Next, this would be, let's do 4 times 4, and the other one would be 4 times 11. The 4s divide out, and you're left with 4 11ths. Here we want to find two fractions equivalent to 25/85. So if it's equivalent, they have to have the same value but just different numbers. So one way you can do this is we can reduce this by dividing by 5/5. 25 divided by 5 is 5. And 85 divided by 5 is 17. So one fraction would be 5/17. And then I can't reduce that any further, so what if I go back to the original one and had 25/85, and I multiply this by 2/2, which will give us 50, and 85 times 2 will give us 170. So those would be two possible equivalent fractions. Next, find two equivalent fractions to 15/27. So here, if I have 15/27, I can divide this by 3/3, and I would get 5/9. So that's one way. Now, if I multiply this by 2/2, another way, another equivalent fraction would be 30/54. So when you write equivalent fractions, it could either be bigger or smaller. So you can either multiply by an equivalent fraction equal to 1 or divide by an equivalent fraction equal to 1. So that's our lesson on greatest common factors.